Okay, we're going to start turning points. It's one of the applications of differentiation. I want to remind you what differentiation is. If you have a curve like this, see down this side, it's going down. So the gradient on this side is a negative. So the gradient is under 0. See on this side of the curve, it's going up. So the gradient is a positive number. See down the very, very bottom, the gradient is flat. So the gradient equals 0. Now if you remember, in a curve, the gradient is dy by dx. You differentiate to find the gradient. So if you look down at the very, very bottom, the graph comes down, down, down. It then turns to go back up. This is called the turning point. So the turning point, usually abbreviated to TP. Sometimes it's called the stationary point. But at that turning point, the gradient is always 0. And if the question asks you to find the turning point, what you do is, first of all, you set dy by dx equals 0 and you find x. Then the second thing you do is you substitute your x into the y equation to get the y coordinate. Because the question will ask you for a turning point, so a point always has an x and a y. Now, next thing I'm going to look at, see how my graph goes down and up. Your graph could easily go the other way around. It could go up, this side the gradient is positive. Where it turns, the gradient equals 0, and down here, the gradient is negative. When it's like this, it goes down to what you call a minimum. So this is called a minimum turning point. And you see when it goes up, it's called a maximum turning point. So this is called a max turning point. Now, there's a very special way you can find out if it's a maximum or minimum without even drawing it. It's step 3 of the turning point. To prove if it is max or min, you find the second derivative and sub in your x value. And if your second derivative works out to be positive, it's a minimum turning point. It's the wrong way around to what you would think it to be. But if your second derivative is less than 0, it's a maximum turning point. And then something very strange happens if it equals 0. I'll just show you what happens. If it equals 0, it's called the point of inflection. Now you shouldn't really get that at your level. What it means, if you can picture a graph like this, see where I'm going up, turning down, turning up. This graph has got 2 turning points, one up here and one there. If you imagine those 2 turning points getting really, really close together, they merge into one. That's what you call a point of inflection, when 2 turning points merge into one. But you'll see what it's like when I go through some of these practice questions. There's not too bad, this topic, to be fair. So example 1. Find the turning point and its nature. Now, if you ever see the word nature, that means i.e. is it max or min of the curve y equals 2x squared minus 7x plus 3. So, in the exam, as soon as I see turning point, I will go turning point when dy by dx equals 0. That's your first point from up there. So I have to work out dy by dx. So let's go over to the side to do that. So differentiate it your normal way. Power to the front and take 1 off. And remember the x on its own disappears. So I want this to equal 0. So 4x equals 7. So x equals 7 over 4. Now, you're looking for a point. So my second bit there, substitute your x into y to get the y coordinate. So your y is up here. So y is 2x. You now know what x is. Take away 7 times x plus 3. Sometimes it's good to put a box around that so you can find it easily. And if you fire all that into your calculator, you will get minus 3.125. So you've found your turning point, the x coordinate and the y coordinate. But you're not finished. You have to prove if it's max or min. So if I just put 0.3 here, so I've got to differentiate again. Make sure you write d2y over dx squared. So differentiate again, you get 4. 4 is a positive number, so it's a minimum turning point. Remember, it's the wrong way round to what you would think. And that's it. That's all you have to do. So we'll try another wee example of that and see how we get on. So example 2. Find the turning point of y equals 7 minus 8x minus x squared. So remember all the wee points. First one, you want dy by dx equals 0. So first of all, I've got to work out dy by dx. 7 disappears, x disappears, power goes to front, take away 1. So I now have to set that equal to 0. So we just solve that your normal way. So x is minus 4. Remember, you're looking for a point. You need the x and the y coordinate. So let's stick your x into your y. So 7 minus 8 times x. Just watch those minuses as normal. Always easy to make a mistake there. Minus 4 squared is 16. So 16, add 7, give me 23. So I've got my point. Minus 4, 23. Don't forget to find the nature. And if you remember how to find the nature, you need the second derivative. Now if you differentiate that, it disappears. Differentiate. Like sometimes you differentiate, you're left with an x. If that happens, you just put your x in and see what happens. This time, it's beneath 0, so it's a maximum turning point. And that's that one finished. I think this first wee bit, when you do a second derivative, it will always give you a normal number rather than having an x inside it. But you'll see it later on, and it isn't too bad. So one more to go. Find the turning point of y equals x add 4, 2x minus 1. I can do nothing with that. I have to times out that bracket. So x times 2x, x times minus 1, we go minus sign number letter. 4 times this, so sign number letter, sign is a minus and the number. So the question's asked me to find the turning point of this equation. So how do we do it? I need dy by dx equals 0. Before I do that, I've got to find dy by dx. So power goes to front, take 1 off, x disappears, and the number on its own disappears. So I'm going to set that equal to 0. I think the hardest bit of this is working with fractions. So if you don't want to work with fractions, write it as a decimal. It's no problem. Now you've got to find the y coordinate. So stick it into your y equation. It doesn't matter which y equation you use. I'll just use the first one that they give me. So x plus 4 times 2 times x minus 1. And I'm going to take you through me putting that in the calculator here. So you get a bit of practice of it. So minus 1.75 add 4 gives me 2.25 for the first bracket times. Now the second bracket minus 1.75 times 2, take away 1. So the second bracket is minus 4.5. And times those together gives me an answer of minus 10.125. So there's my point. Minus 1.75 minus 10.125. Don't forget about that nature. So easy to forget. Now where is my dy by dx? Oh, it's up here. If you differentiate that, you get 4x add 7. Well, this is one of the times I do have to put my x in. Sorry, differentiate the wrong thing. So differentiate. She put boxes around them as you go through it. Differentiate that, you get 4, which is greater than 0. So it's a minimum turning point. Now, I would like you to have a go at exercise 8A, and I will post photographs of the answers.